Hello, everyone. I apologize for the previous recording. I have been exhausted and I didn't even notice to see that the recording was just recording my face and none of the work. So I'm going to do this again. I'm going to do a new share. Make sure that it is my screen number 2 that I am sharing, and I'm going to watch it before I send it out. I am going to also let you know that I'm going to be doing 2.1 and 3.1, 3.2 briefly, because this is just a way to add to your knowledge of what you have already seen and done on the homework for 3.1 and 3.2. This is not to mean that this is going to be a lesson of every single detail. If you have questions, you can definitely ask me. Either by email, putting them on the announcements, or sending them in the discussions amongst each other. But more importantly, it is your job to watch the recordings, the media, all the information that is up there on Pearson, and just go through these recordings as a way to complement what you have already done and known. Okay, so let's start with this. Let me start with the complex numbers. Complex numbers. We are going to be moving into the complex. The previous chapters were just dealing with real numbers, real answers. In this case, complex means the imaginaries. And I know it's going to be hard to understand that concept, but just for purposes of some of these chapters, let's just try to understand it. When we are talking about solutions of parabolas, or any shape for that matter, any graph for that matter, we need to understand that the solutions to any system are basically the x-intercepts, okay? When you are looking for the x-intercepts, visually, however many times you see the graph cross the x-intercept, that means the actual real solutions, okay? If you do not see it cross, for example, here, that is a no real solution, but there are two imaginaries, okay? So 2 real solutions, the word real means you can visually see it. So that means twice that it crosses the x-axis. 1 real solution, that means it crosses the axis exactly once. And no real solution, 2 imaginary, basically means it does not cross it at all. Okay, how do you find the solutions of a system when they ask you to do it algebraically? You basically set the equation equal to 0, as you can see here from what I wrote. And visually, graphically, you would state the x-intercepts. Those are synonyms of each other. All right. Now, again, this is something that you should already have seen. This is not for you to go through my whole lesson and be like, wait, this was just way too rushed. I'm not trying to rush it. I'm just going through my notes that I have already up there. Okay. So more importantly, I do want you to already know some of this prior to coming in here and watching my recording. The whole idea behind I, okay, this was not here. So the square root of a -1, if you put it on your calculator, is basically an error. So let's take, for example, my calculator here, and let's try to put that in the calculator. I gotta change some things here, hold on. Okay, so I'm going to try to input the square root of a -1. Okay, make sure that when you put a negative, it's a negative here, not this one, that's a minus. And I'm covering this up because that's going to come out, that's going to come later. So when I press enter, I get an error and it says quit, right? So when you are dealing with this chapter, and if you want, you can just change the mode for the rest of the class. You can, this will give you an error, of course. You can change it to the following mode so you get the imaginary answers. So you're going to go to mode, and you're going to go down to this part. And right now, reals is selected. So every time you put something that's not legal, like negatives under square roots, then it's going to give you an error. All right, now, since we're in the chapter where we don't want it to give us an error, and we want to speed up some of these questions, I'm going to go and change it to A plus BI and select. Okay, so that needs to be highlighted. See that? Okay. And then I'm going to quit second mode. Now, when I have that and I press enter, look what I get. I get the I. So anytime you have a negative under a square root, I take it out as an I. That I comes out, and then you take the square root of that number. Square root of 1 is just 1. 1 times I is I. And that's how you get that answer. Okay, so like I said, you need to practice this a bit more and understand what this means. All right, now when you take the square root of -1, which is equal to I, and you square both sides, if you see my pencil very lightly, it cancels the square root. When you square, obviously, both sides, square root and squares cancel, but it moves a square to the other side. So basically, this is I squared equals -1. And this is what you're going to need for your note card. So make a note of this, possibly make a note of this, write it down, make a picture, whatever you need. Just make sure you don't write examples. But this you will definitely need. All your answers will be written, all your imaginary answers will be written in A plus BI form. A plus BI form. Okay? So if it's not in that form, it will be wrong. It'll be marked wrong. Okay. All right, moving along. If I ask you to evaluate the following, okay, let's start with this one. So let's suppose, notice here the purple. The original problem, number 1, is the square root of -16. Square roots of negatives cannot happen, so you take out the negative out as an I. I literally do this curve and I dot it, and that becomes I square root of 16. Square root of 16 is 4, so it's just 4I. Okay. All right, the next problem is a negative coming out of the square root. That's the square root of 75. That becomes I square root of 75. You have to break this down. This is not a perfect square like the previous problem. You have to break it down into prime numbers. For every pair, you take a copy out. So 5 comes out of the square root. Okay, leaving a loner, the 3 inside with the I outside. I was asking some colleagues of mine, and I tried looking into the calculator to see if the calculator would give you the square root of 75 as a reduced radical on the graphing calculators, but I did not find it. So you do have to do some kind of procedure to be able to reduce it yourself. But this is not too bad. Okay. And if you need help with that, again, you can do it. Okay, moving along. We've got multiplication here. When you are multiplying, okay, before you multiply your numbers, when you have 2 numbers, however many numbers inside radicals, if it's the same radical, you just multiply them. You would just multiply. The issue here is that this one has a negative. So you want to take that out first, have that as a 9. Make sure that these are positives. Then you can multiply. 7 times 7, which is 49. Square root of 49 is 7. So you always want to be able to make sure that you are taking out those i's if they are under a square root, but just in general, an even root. All right, over here, this is a negative. Like I said, do not multiply them first. Take out the I first, take out the I first, because there's a negative inside the square root, negative under the square root. That comes out as I squared of 6, I squared of 10. Now you can multiply the insides, and then you can multiply the outsides, which is why I got I squared root of 60. You break down the 60 over here, prime numbers. For every pair, I take a copy out, so I took a 2. The loners, 5 and 3, multiply together to give you 15. I squared, if you remember, it's a -1. So that turns into a -1, which is a -2 square root of 15. Okay, and again, this is explained more into depth in your Pearson math lab. Right over here. This is division. So when you are dividing or multiplying, it doesn't matter, or you're adding or subtracting, it doesn't matter. The first thing you do, if you see again square roots, negative under square root, boom, take it out. Boom, take it out. So out, out. That's I square root of 20 over square root of 2. They come out and they cancel because an I over an I is 1, so they cancel. Square root of 20 over square root of 2. So you need to break these down, or because they are dividing, you can actually put them under the same house, under the same roof, as I call it. So square root of 20 over square root of 2 is the same thing as square root of 20 over 2, which just gives us 10. Okay. Okay. The next one is exactly the same thing. You take out that negative as an I. You then do square root of 48 over square root of 24. You can put it all under the same radical. If they reduce, that's the square root of 2, and that is done. Okay. So these were fairly easy. You did not end up with radicals in the denominator. Okay, I'm going to do some more division where that's the issue and we have to fix it. Okay, so rule 2 is something that you would also might want to incorporate on your note card. No i's in the denom, no imaginaries on the denom, no radicals in the denom. I squared equals -1. All right, just remember that rule. It's going to come up a little bit later. When you're adding or subtracting, you just literally put the like terms together. You are not to distribute, number 5, because of the fact that these are not multiplying. Had this not been here, it would be multiplication, but it's not that case. So you have to just basically add like terms with like terms and end up with your answer. Now I ended up with 2i plus 1, and it doesn't matter what I end up with. You always want to put it in a plus bi form. A plus bi form. Make sure it is in that form so it doesn't get marked incorrectly. Okay. Number 6, this is a subtraction problem because there is a subtraction in the middle. So what you do is distribute the negative, drop the parentheses, and then add the numbers together, put it in a plus bi form. A plus bi form just means, focusing, a plus bi form just means put the number first and then the I. Okay, put the number first and then the I. Okay, let me do this autofocus lock because it keeps moving and changing. There we go. All right. Again, I'm just skimming through this because it shouldn't take too long. All right, now the second one, the second part of multiplication, that does require you to then FOIL, okay? Just like you would any binomial that has variables, just like that, okay? So when you FOIL, you do exactly the same thing. You treat I as a variable because technically it is. But when you encounter the I squared situation, that changes that term to a negative, or the opposite sign, better said. Once that changes, then you have no more I squareds. You should not have I squareds anymore. End of story. Like, you cannot go around that rule. No more I squareds. They're supposed to disappear. I squared equals -1. You should just end up with numbers and i's, single i's, and you write it down in the specific way, a plus bi. And this is how this I squared disappeared, because I squared is -1. Okay. Looking at this other example, you do not square the 4 and square the 3i. That's illegal. You are to multiply these two binomials together, and you end up FOILing. When you end up FOILing, obviously you end up with a variable squared. That variable squared is a -1. That then makes this 9 a negative, and then you put it in a plus bi form. Okay. I was gonna say no question. But anyway, again, when you are dealing with these, the quotients, the division, you have to make sure you remember that there are no i's in the denom. No i's in the denom. And you are also going to remember this rule. It's multiplying by the conjugate. The conjugate, I did not, okay, the conjugate, so I'm going to go over that first, okay? But more importantly, no i's in the denom, and multiply by the conjugate, multiply by the conjugate. So you are going to look at the bottom, okay, before I do any of that. What is the conjugate? The conjugate is used when you have a binomial and you do the opposite sign in the middle. I notice how if I'm asking what is the conjugate of a plus b, you do a minus b. You do not change the sign on the a, just the middle. When I ask you the conjugate for a minus b, you would say a plus b. And so why is that? Because when you end up multiplying this with its conjugate and a minus b with its conjugate, so like you see, multiply with its conjugate, I end up with a difference of squares. Why is that? If you FOIL the entire piece, you end up with a squared, you end up losing the middle piece and then minusing the last squared. So for purposes of this, I'm going to show all the steps, but just know that the conjugate of multiplying two conjugates together basically produces a difference of squares formula, which gets rid of the middle piece, which would relieve any i's from staying in the equation. So let's start with this. Now, this does not require a conjugate because it is not a binomial. However, I do have an I in the denom. I's and radicals are not allowed in the denominator. You have to either rationalize or rationalize. You don't have a choice. So how do I get rid of the I? Well, I just take another I because I times I is I squared, which then removes it and makes it a -1. So if you multiply top and bottom by the same thing, it's like multiplying by a big one. Multiplying by a big one means you have not changed the original equation or expression, and that's what you don't want. So you multiply numerator and denominator by I. So the bottom becomes I squared, the top becomes 5i. Do not reduce, people, please do not reduce. If you reduce and cancel this I with this I squared at the bottom, you'll end up with the original and you'll be in this vicious circle. So please do not cancel the i's, just keep it like that because that's going to make I squared a -1 and leave the top as 5i. We do not care if i's are in the bottom. There's no way that you're going to get rid of the I completely. It's just going to be moved to a different place. And it's okay if it's moved to the numerator. We just don't want it to move to the denominator. Okay. So I squared is a -1. You then have this negative. So that moves up when you divide anything by a negative. It just basically becomes a negative of that. So -5i would be the final answer for this. That's it. Okay. So the next one, we have a binomial. So whenever we're trying to do this, you would multiply by its conjugate. The conjugate of 3 plus I is 3 minus I. You do not multiply just the top and the bottom by I. That will not be enough because what's going to happen is, let's suppose I multiply the top by I and the bottom by I. In the bottom, I'll end up with 3i plus I squared. So it'll get rid of the second I, but not the first one. And you're just creating more problems for yourself. So make sure you multiply both the top and the bottom by the conjugate of this. And once you do that, you're going to end up foiling both the numerator and the denominator. However, when you multiply the bottom pieces, because they are conjugates of each other purposely done, your i's should completely disappear. You should end up with a number. If you don't end up with a number, you've made a mistake. All right, so let's go ahead and do this one. I thought I had it, but it is not. So I just wanted to get you started on that. Okay. All right. So for this part, okay, you've got the foiling of the numerator, which produces all of this. It produces 21 minus 7i minus 3i plus I squared. The bottom gives you 9 minus 3i plus 3i minus I squared. The middle pieces cancel, and that's our whole goal. Our whole goal is to cancel that single i's, okay, minus I squared. So that gives you 9 minus, because of this minus, and I squared is a -1. That gives us 10. In the numerator, we have 21. We put these two numbers together. That's -10i. And then this I squared is a -1. And then you put all the numbers together. So 21 minus 1 minus 10i. And then this is just a 10. So let me show you how this how this gets reduced. I don't know where it went. These were the notes that I had made last time. So let's just finish it here. You're always going to write your answers in A plus BI form. Okay, so basically 21 minus 1 is 20 minus 10i all over 10. That is not in A plus BI form. Okay, it is not in that form. So that means that you have to separate this. They have to be separated. Okay, so you end up with 20 over 10 minus 10 over 10. Please try to separate it first and then reduce. A lot of students will try to reduce all three at the same time and they reduce it incorrectly. So I separate it first and then I just go ahead and reduce this, produces a 2. That produces a 1i. Done. So your final answer is 2 minus 1i or 2 minus I, which is the same thing. Okay, and that finishes part B. Letter B. Okay. Okay, that's that. Okay, so this you can do on your own. You can do it for you. Okay. Again, this you multiply by I, top and bottom, I get negative 3i. This is I squared, and then these negatives cancel, producing a 3i. So go ahead and practice these. You finish this one. And then the conjugate situation is down there. Okay. All right, moving on to number 4. All right, when it comes to graphing is not really emphasized, and I don't really want to emphasize it because it's not that big of a deal. However, I still want to go over it, okay? So when you graph these, it's the same thing as the XY coordinate, but instead of XY coordinate, it's called the reals versus the imaginary, okay? So reals. This is like your X. And this is your imaginary. So when you're given a number, you want to know that this A, the first number, single by itself is like your X. Okay. And your second number that is next to the I is your imaginary, which is your Y. So when you are graphing, let's say negative 5i, that negative is your B. So that would be a negative 5. And it doesn't have an X, so that's 0. I know it's hard to see the 0. I'm gonna like that. Okay. So that's why the A is 0, negative 5, and that's a dot down here on the y-axis. Okay. The next one is 2 minus 1i. So that's the same thing as 2, comma, negative 1. I'm going to make it 2. Should have used maybe another highlighter. That's fine. So 2, negative 1 is this point right here. Down here, 3i is the same thing as 0, comma, 3, which is this dot up here. And this is just a single number, which is 5, no imaginary. That would be 5, 0. 1, 2, 3, 4, 5, 0. Okay. And again, these are fairly easy. I didn't put a lot of these just because it's not emphasized as much on the recording, on the media, on the lesson, and I don't want you to take too much time thinking about that. All right, that ends 3.1. 3.2. let's go over these. So we're going to be looking at quadratic functions. Quadratic functions are the happy faces or sad faces. We've got standard vertex and intercept form. You have the intercept form on that form that I have up there. So make sure that you please look at that. You may use it on the exam. Standard form is this form. Doesn't matter if it's y equals or f of x, it doesn't matter. And vertex form, again, doesn't matter if it's y or f of x. Standard form is ax squared plus bx plus c. This is the one that we want to use when using a quadratic formula, because this you cannot extract your a, b, and c. You have to FOIL this in order to go this way. So if you want to put something in vertex form and make it into standard, you have to FOIL that. You have to expand it and make it that. If you want to go the opposite way from standard to vertex, that's a little bit more rough to figure out, and that requires the completing of the square, which is another one of the worksheets that I have up there. So A, B, C are numbers, A, H, K are numbers. You've already seen this before. This is the HK form from many of the parent graphs. Remember, from parent to the transformation. This is basically that specific form. All right. So how are we going to do this? Complete the square to go from SF, not San Francisco. Okay, I know we're all in COVID, but no. Is complete the square to go from standard form to vertex form. And you've got this kind of equation. So let's check it out. How exactly do we do that? Well, the first thing we need to do is to, when I ask you to complete the square, if I ask you to complete something, it must be missing something. And it doesn't look like it is. It looks like it has all the pieces together. It's got an A, a B, and a C. So, let me cover this up. Okay, so what I did was, the first thing I did is to change this to the letter Y. Okay, the next thing is, if you look at the vertex form, you have a binomial squared. You have to have a piece squared. That means that I need to have something that's the same twice. All right, so let's look here. If I factor this out, okay, if I factor this out, let's see if it is factorable first. You're like, okay, I got 1 times 8 and 2 times 4. And it is true that when I do x plus 2 and x plus 4, I do get this. But are these factors the same? No, they are not. I'm supposed to have something like this. A binomial squared. So the same binomial squared. I cannot put these two together at all. I cannot put these two together at all and say, oh, it's x plus 2 squared, or it's x plus 4 squared, because these are not the same. So that's when we see that our 8 is useless. Our 8 is useless. And we have to find a way to then make a number, come up with a number that will allow us to complete the square. Now, it obviously says like completing the square. When you complete something, it must be that it's missing something. So it's not missing anything yet, but we're going to make it miss it. So what do? There's two ways of doing this. One way is to just grab the 8 and just pull it aside to the right. Some people don't like to see it on the right side. Some books don't leave it. They actually move it to the left side. But that to me is just a lot of movement of stuff. So I just move it, because then at the end you have to move it back. You have to remember to move it back. Okay. So what I do is I just move it to the side, just like that. Okay. And I create a little square or a box, okay? Whatever I put in here, whatever I add, you always have to balance it out with subtracting it, because if I give you something and then I take it away, it's a 0. It's like I never gave it to you. So you always have to add and subtract that number that you added, so that it means like you never added it. It's kind of like multiplying by that 5 over 5. It's basically multiplying that 5 over 5, which is just 1. And that means like you never really changed the expression. So over here, it's the same idea. When you add something and you take it away, you basically never did anything to it, okay? So you can add anything to an equation as long as you counteract it with its subtraction. So this means that I need to know that about the special number. How do I find this special number? I can put any number in there, but it's got to be useful enough to help me complete the square. That number is obtained by taking this number, the 6, cutting it in half and squaring. So here we go. I take the 6, cut it in half, square it. So inside I get a 3. I square it, I get a 9, and that 9 goes in here and in here. So then I end up with this situation. Okay. Now in here, this is a trinomial that's going to be factored. Over here, you just put those two numbers together. That's not a big deal. All right. This page can go. So when you factor this trinomial, now it's going to give you a perfect square trinomial, which is x plus 3 and x plus 3. Now notice that the two binomials are exactly the same thing. So x plus 3 times x plus 3 is the same thing as x plus 3 squared minus the 1. And that is now in vertex form. Now, do you have to sit there and factor this trinomial like from scratch? You're like, oh, do I have to remember how to factor? Well, first you do. You have to remember how to factor it. But the trick to go, you can actually go from here all the way to here. You don't even have to like do this factoring process right here. The shortcut from going to the trinomial and the binomial squared, because you made this yourself, that number 9 is, I mean, if you did it correctly, then this binomial squared comes about from the previous step. You drop the variable, which is your x, and you put the number before you squared, which is a positive 3. You square, and then you do the math on the side. Okay, and that is completing the square. So that number, that positive 3, is a number before squaring. Okay, that is how you complete the square. Okay, you need to practice more times. All right, let's do example 2. I don't know, I have this paper in this one. P of x equals 2x squared. Okay, in order for you to complete the square, a has to be 1. It is not 1. There's a 2 in it. Okay. Okay, so what needs to happen is, if let's say that you decided to divide by 2, good for you. You can divide by 2, but that 2 is gonna be you're also gonna have to divide the y by 2. So you're not really technically getting rid of it, you're just temporarily moving it to the left side. So you can go ahead and do that. You can literally, take that situation, that number, let me grab another pen. You can just say, well, this is confusing me, so I'm gonna divide everything by 2. You could also factor it, but do not just ignore this. Do not say, oh, I divide everything by 2, it's gone, and this doesn't even exist. No, that 2 got also divided to the left. Okay, now this is not a perfect trinomial. Okay, if I were to factor this, I do not get a 2. Okay, so I am going to say, you know what, -8, you are useless to me right now. So if I add a box, I'm going to have to subtract the box. Okay, so we can go ahead and move that one away. And this number right here is going to be the number in the middle. You're going to cut it in half and square it. It's going to give me 1 squared. My answer is 1. That goes in here and here. Okay, so this is y equals, that's going to be a binomial squared with these two put together, which is a -9. The trick to going from here to here without having to factor this trinomial is just basically drop the variable, and it's just basically use the number before you square. That's a positive 1. You're going to keep the sign in the middle. Okay, and this is now vertex 1. All right. So that takes us to 2 more pages. All right. That takes us to, let's see what I've done last time. Okay. So then it's followed by this. Okay. So this is just information. By the way, this is not an actual problem. This is just a recap and a reminder of how the HK form works. You've got the HK. If A is positive, it's happy because it's positive. If A is negative, it's a sad face. Okay. When you do the HK, you take the opposite of the first one and you put it down. The second number is you keep the same sign. That's why I put keep sign. Then according to what you have on this line H and on this line K, you then figure out whether you move left or right. So if the H is positive, you move to the right. If it's negative, you move left. Vertical, up or down, because these are happy faces or sad faces. For all of the parabolas that are happy or sad, the domain is all reals because they go left and right forever, whether it's moving up or downward. And the range depends on the low point, if it's a happy face, and the highest point because it's sad face. The axis of symmetry will be x equals a number. Do not just put the number because you will get marked down. X equals a number because that's a line. That's the vertical line that cuts the parabola through the middle. And then your minimum and your max is your K. So these two numbers say a lot about the parabola. Okay, so you're going to be encountering projectile motion. Some books have the letter S. Some other books have the letter H for height. So it doesn't matter, it means the same thing. This little circle at the bottom is not, that's a not symbol. And in math, that little circle, it's sort of like a circle, it's not really a zero, it's like a circle. And it really means initial, okay? So whenever you see a variable in the little circle on the bottom, it means initial. So this, your equation for projectile motions, anything that you're throwing up in the air, and you will have this on the exam, will be using this equation. They'll either give it to you or you have to plug in the numbers. So negative 16t squared, t is for time, that would be our x variable, plus initial velocity, they'll give you a number for that, times your time, which is your x variable, plus your initial height. So wherever you started, that's the initial height, and that's going to be equal to your final height. All of the variables are stated on the right. Okay. So let's go through this word problem. However, I'm going to ask you different. So you can take this word problem and answer these questions yourself. I'm going to ask a few other questions so that you can just get the hang of this, okay? So it says a ball is launched upward from the ground. So from the ground, that's the height, with an initial velocity of 150 seconds squared, okay? So what do you do? Let me something. Okay, so you are to come up with the equation of this formula. I'm going to ask you a few questions. All right, so the first thing you do is you write down, you understand that it's coming from the bottom, from nothing, from the ground. And so you write down the equation and you start filling out what you need, what you have. This is part of the formula. I changed it to H just so you can understand that it's the height, but either equation is the same thing. Some books have an S, especially the physics books, and then height, a lot of the algebra 2 books have it. Initial velocity is 150 feet per second. That is a velocity. So that gets replaced for V sub 0. The height sub 0, so the initial height, because it's coming from the ground, it means it was at 0. There is no height because it's 0. Therefore, our equation should be the following. Okay, that should be our equation. Once we have our equation, I can ask you anything regarding this equation. Okay, so let's ask you, for example, what's the height after 2 seconds? So this is a parabola motion, and the x is time, and the y is the height. And I asked you, what is the height after 2 seconds? That means this is time. Of course, 2 seconds is time. And you want to know the height. So you're going to plug in 2, 4, t. And that's it. H of 2, and that's going to produce whatever number that's going to mean the height at that specific time, which is 2 seconds. Okay? See this in there too. Last question is, at what time does it reach its maximum height, and what is the height? So looking at the picture again that I have up here, if this is a parabola and you are looking for the maximum height, you're basically looking for the vertex. Now, that sheet that I have up there that you can use on the exam, where it's got standard form, vertex form, and intercept form, it shows you how to find the vertex of each of those in every specific form. So in order for me to find the maximum height, first of all, you have to, well, you're trying to see where the vertex is. You have to know which form it is in. This is in standard form. Okay? So because it is in standard form, the way you find the x-coordinate of the vertex is you take the opposite of b and you divide it by 2a. I don't like to say negative b because some students see that as, oh, it's got to be negative. No, it doesn't. It's the opposite of b. Whenever in math we have a negative, it means basically the opposite. And to find the y, you basically plug in the x. So the math is opposite of b divided by 2a. I did the math and I ended up with about 4.6875 seconds. The book will always tell you, or the Pearson will always tell you what to round to. So I just wrote everything out because this was an exact number. To find the height at that specific time, you do the same thing that you did with f of 2, h of 2, you just plug it in. And you end up with this specific number because it is an exact number. It's an ugly number, but nevertheless exact. Okay, and that's how you would do these questions. Now, they're not the same questions on the notes, but with this kind of information, you then should be able to figure out what they ask, especially now that you have the equation given. Okay, so you can go ahead and solve that. All right, the next one I'm going to do is number 6. Okay. This is find an equation in both vertex and standard form given this vertex and through this point. Okay, so if they give you the vertex, you want to use the vertex form. Okay, because plugging this in into the ax squared plus bx, ax squared plus bx plus c is impossible because you don't have those letters. So let me move it aside and let me start. Okay, so I just rewrote it again. All right. This is your h, that's your k. Whenever they give you the vertex, that's hk. Whenever they give you any random point, that's x1. So we're going to use vertex form, and we're going to plug in everything we know. We know x, we know y, we know h, we know k. We're going to find a. This is what we are looking for. We are looking for that a value. So if we do this, we plug in everything. That's my a. We use order of operations, PEMDAS. You do what's in parentheses first, then you do the exponent, and then you subtract, and then you divide. So when you do this, you should end up with a is a half. Okay. So you can check out the math, do it yourself. I don't want to take time doing that. A is a half. If a is a half, then you would plug that back in because you already know now. You now know a. H and k. You do not plug in the 10 and the 5 back in here when you give your final answer. When you give your final answer, you just need a and hk. A and hk. Okay, so my answer in vertex form is going to be 1/2 times x minus 8 quantity squared plus 3. This is my h, and this was my k. Okay, so that is vertex form. If I needed to find this same form and put it into standard, I'm gonna have to FOIL that out. That's what I did here. Okay, do not just square the x and square the h. That is very illegal. That will never get you the right answer. That will just get you to take points off because you did not do this correctly. Okay, this is the last problem. So you FOIL that first. I did the math there. I put the like terms together, and then I had a half outside. I still have parentheses. So I'm going to distribute this half with everything. If some parts, if some of these numbers are divisible by 2, great. If they're not, that's okay. I then take half of everything, and I don't forget about adding this 3, and that gives me standard form. So in order to check, let's say you're on your homework or you're on the test, if you wanted to check if these two are the same, you would actually plug in those two equations in here. Y equals, I'm going to plug in 0.5 left parentheses x minus 8 squared plus 3. Did I do that right? It's kind of sorry. And then 0.5 x squared minus 8x plus 35, and then I graph. So watch it graph the first one over there. If the second one, that's working on, doesn't graph it right on top of it, then you did it wrong. How do you know it's on top of it? Because it didn't make another one anywhere else. Okay, so it meant it was the first one. How can I be for sure that it's the same graph? I go to trace, and it's going to give me the equation up there. I don't see the cursor, so let's get the cursor somewhere on here. I'm going to go to the right until I see the cursor. My x value is 4, so it's somewhere in here. It's going to show up. There it is. So if I take that cursor to the right, it's on that graph. But how do I know where the other one is? You hit the up or the arrow, the up or the down arrow, and that's going to take that dot and move it to the other graph. So if it doesn't move it, if it doesn't move that dot, it means that it's the same graph. So then if I go down, see, it changes the equation, but it never moved the dot. If I go up, not even the point moved because it's the same point on the graph. It's just different equation. But look, it looks different, but it's the same equation. Same dot, same x and y, but different equation. Okay, it's just written different. That is correct. So that's it for 3.2. I'm going to do the next recording for 3.3 and 3.4. Let me just stop the recording.